All right, we're about to dive into this incredible story of geological alchemy, something that happens deep, deep within the Earth. In this explainer, we're going to uncover the genesis of one of the planet's most unique rocks, soapstone. So let's just start with the central paradox, right? The thing that makes this rock so fascinating. How is it even possible for one of the hardest materials born in the Earth's mantle to transform into one of the softest rocks on the surface? I mean, a rock you can literally carve with a knife. It just sounds impossible. But that's the journey we're about to take. You see, this entire story really hinges on a single, super surprising fact about where soapstone actually comes from. Believe it or not, before it becomes that soft, carvable soapstone we know, this material starts its life as an incredibly hard, dense rock forged deep within our planet. It's kind of like the ultimate geological glow-up, and we're going to see exactly how it happens. Okay, so to really understand this transformation, we've got to start with the source material. And that means we're going deep, deep into the Earth's mantle. So the original rock is what's known as an ultramafic rock, something like peridotite. Now, ultramafic sounds complicated, but it just means it's absolutely packed with magnesium and iron. It's born in the crushing pressures of the mantle, and it's made of really hard minerals like olivine and pyroxene. So just picture this: dark, heavy, crystalline. It's the complete opposite of a soft, soapy stone. This is our before picture, right? So, if that's our starting ingredient, what's the recipe that turns this super tough rock into something so soft? Well, it's not magic, it's chemistry. Let's break down this recipe for softness. The entire transformation really boils down to three crucial steps. First, you add water. That kicks off a bunch of hydration reactions that start to weaken the rock. And then, finally, those reactions lead to the formation of the one mineral that changes everything: talc. Step one is all about the water. It is the catalyst for absolutely everything. See, as these hard mantle rocks get pushed up towards the surface, maybe at tectonic plate boundaries, they encounter water for the very first time. And that water seeps into all these tiny cracks, acting like a key that unlocks this whole chemical chain reaction. Seriously, without water, this transformation just doesn't happen. And that brings us to step two, a process with a fantastic name: serpentinization. The water starts to react with those hard olivine minerals inside the rock. And the result? Well, they transform into a completely new type of mineral, these softer, hydrated serpentine minerals. The rock is, well, it's fundamentally changing its identity. Now, this process has some really big physical consequences. As the rock hydrates and forms serpentine, it actually expands. It gets less dense, and most importantly, it gets a lot weaker as its rigid crystal structure breaks down. But, and this is a big but, this isn't the final form. We're not at soapstone just yet. Okay, this is it, the final, most critical transformation. The newly formed serpentine keeps reacting with other fluids that are just circulating around in the crust, specifically fluids that are rich in silica. And this second reaction, this is what creates the mineral that gives soapstone its name and all its famous properties: talc. So here's the crucial point. Talc is an incredibly soft mineral. It's actually made of these little sheets that slide past each other really, really easily. And that's what gives it that slippery, almost soapy feeling. At its core, soapstone is just a rock that is absolutely packed full of talc. And here it is, the big aha moment. On the Mohs scale of mineral hardness, where diamond is a 10, talc is a 1. A 1! It is literally one of the softest minerals on the entire planet, and that is the answer to our paradox. The transformation from one of the hardest materials to one of the softest is now complete. So let's just recap this incredible journey, okay? We went from a hard, dark, crystalline rock born in the mantle all the way to a soft, light-colored, smooth, metamorphic rock. Every single property, from its hardness to how it feels in your hand, has been completely flipped on its head, all thanks to some water and a little bit of chemistry. Now, this isn't just some cool chemistry experiment. This process has absolutely massive implications for our planet. The creation of soapstone and its precursor serpentinite actually creates literal weak points in the Earth's crust. So where does this all go down? Well, you find soapstone in areas of really intense geological activity. Think subduction zones, where one tectonic plate is diving underneath another, or mountain building belts.
Essentially, any place where those deep mantle rocks are getting shoved upwards and forced to interact with water.
And here's the critical insight. When you create these soft, slippery rocks right along tectonic plate boundaries, you're essentially lubricating them. It's like greasing the wheels. These zones of serpentine and soapstone become mechanically weak. So instead of locking up and building up all this stress that leads to massive earthquakes, these zones can sometimes allow the plates to just slide past each other more smoothly. It's a process called aseismic creep. It's incredible. What happens inside a single rock can literally change how entire continents move. So let's bring it all together. This has been a pretty incredible journey, right? Following a rock from the deep mantle all the way to a sculptor's workshop. If you take away just one thing from all this, let it be this. Soapstone is what you get when a hard rock from the mantle is fundamentally changed by water and metamorphism. The end result is a new rock that is defined by one thing, that incredibly soft mineral, talc.
And that's really the wonder of it all, isn't it? You have a piece of the Earth's deep, violent interior that gets brought to the surface. It meets water, and it becomes so gentle, so soft, that it can be shaped by human hands into a work of art. That right there, that is the power and the poetry of geological transformation.